This section begins on section R2, page 11 of week 2. It deals with the quotient rule of dealing with exponents. So if we have x, which is any non-zero real number, so it's basically any real number except for 0, and m and n, the two exponents, are integers, then the following simplification is something that we can use. So we have x to the m divided by x to the n, so it looks like a fraction, and the answer is going to be that same base, and we subtract the exponent on the bottom from the exponent on top. So let's look at a case, x to the fifth divided by x to the third. We're remembering our definition of what an exponent was. X to the fifth means 5 x's that are multiplied. X to the third on the bottom mean 3 x's that are multiplied. So what we can do is take 3 pairs of them and cross out 3 pairs. If we do that, we only have 2 x's left on top, and we have no x's left on the bottom. So we would have x to the second over just a 1, and we use a 1 when there's nothing left. So our answer is going to be x to the second. We're using the rule, the quotient rule, which is much easier. We would take x to the 5 minus 3 and get the 2. Using more examples of this, we have x to the 10th divided by x to the second. We would take the 2 on the bottom and subtract it from the 1 on top. So we have 10 minus 2, or x to the 8th. Another way of looking at this is you have 10 x's on top, 2 x's on the bottom. Where do you have the most? You have the most on top, and they're going to stay there. So you have x to the 8th. Something that is not in the textbook that you can use: if the exponent on the bottom is larger than the exponent is on top, you can subtract the exponent on the top from the one on bottom. This actually works all the time, but you might get a negative exponent, and both of them will work regardless. So you can do it either direction. As an example, I would say that most of my students prefer to use the one illustration that was in the textbook of subtracting the exponent on the bottom from the one that's on top all the time, and not using the optional one. But they're both there if you want to try them. An example of using exponents again, using the quotient rule, is x to the second divided by x to the 10th. Using the rule in your textbook, you would take 2 minus 10. You would get x to the power of minus 8. Again, remember that you can have x to the minus 8 for homework answers, for any of those homework problems that you want to turn in. On the test and the practice test, I would like to see your answer expressed with all positive exponents, so we would want to turn this one into 1 over x to the 8th. On page 12, we have 3 more examples. X to the 12th divided by x to the 3rd is x to the 12 minus 3. Again, we subtract the exponent on the bottom from the one on top and get x to the power of 9. You can use that as x to the 9 over 1, or just x to the 9. What we have here is 12 x's on top, 3 x's on the bottom. Where do you have the most? They're on top. And how many more do you have? 9. On the next example, we have y to the 3rd divided by y to the 20th. Using the rule in the textbook, again subtracting the exponent on the bottom from the one on top, we have 3 minus 20. 3 minus 20 gives us y to the power of negative 17. That answer is fine for a problem on your homework. For the test and the practice test, again, I would like to see it listed as 1 over y to the power of 17. The third example here is we have x's and y's, combinations of them. So we work entirely with the x's, and then we work with the y's. So we have here x to the first over x to the third. So we would have x to the 1 minus 3, or x to the negative 2. If we write our answer with only positive exponents, we would have the x to the second would be on the bottom. The y's, we have y to the 5th divided by y to the second. We have 5 minus 2 gives us 3, so those y's would be on top. So looking at our problem again, we have 1 x on top, 3 x's on the bottom. Where do we have the most? On the bottom, and we have 2 more. We look at the y's, we have 5 on top, 2 on the bottom. Where do we have the most? On top. So we have y to the 3rd on the top. So our answer can look like this: y to the 3rd divided by x to the 2nd, or we could have x to the minus 2, y to the 3rd, and that answer would be fine for any of your homework problems. Our next example down looks a lot more complicated, but what we're going to do with this problem is, if you look at every exponent, we're going to take the ones with negative exponents and put them on the opposite spot. So 3 has an exponent of 1, it stays on top. X to the minus 5th has a negative exponent, we place it on the bottom as you see in the middle example. Y to the minus 6 has a negative exponent, so we're going to put it on the bottom also. 27 has an exponent of 1, we leave it where it is. X to the second has a positive exponent, we leave it where it is. And y to the minus 8 has a negative exponent, so we're going to move it up to the top. So there we see our middle fraction. On our middle fraction, we have the fraction 3/27. 3 will divide evenly into 3 one time, and 3 goes into 27 9 times. So 3/27 is the same as the fraction 1/9. For our x's, we have x to the second times x to the fifth. So we're going to use our product rule that tells us to add those exponents together and get y to the 7th power. We look at our y's and we have y to the 8th divided by y to the 6th. So we use our quotient rule, which we just had, and we take 8 minus 6 and get y to the 2. So our answer to this problem is going to look like y to the 2nd over 9x to the 7th power. There are a lot of different ways that we can work these problems now. We can work them simply by subtracting the exponent on the bottom from the one on the top, in which case if we did that we would get x to the negative 7, y to the 2, and then on the bottom we would have the 9. So your answer can be expressed as either way, but this answer is the way that I prefer it for the test and the practice test. On page 13 we have something called the power rules, and there are 3 different sets of those. You'll see that there's A, B, and C going across the page. We're going to look at the first one, and it has one base of x and it has an exponent of m, and then on that one it has an exponent of n on the outside. So it tells you if you have one base and 2 exponents, this is a lot different than the product rule was, where we had 2 bases and 2 exponents. So one base and 2 exponents, we simply multiply the exponents. So the example below A is x to the 2nd to the 3rd power is x to the 6th, where we multiply the 2 and the 3. Examples of power rule A can be done by x to the 4th to the 3rd power. If we expressed it the long way, would be x to the 4th times x to the 4th times x to the 4th. That's using the definition of exponents. If we wanted to use the definition of exponents again, we could make each one of those be 4 and count them up and get 12, or we could use our product rule at this point and add 3 4's together and get x to the 12th. The simpler way to do it is using this power rule, though, is multiplying the 4 and 3 and getting 12. The next example, x to the 5th to the 2nd power, we multiply the 5 and 2 and get 10. X to the 8th to the 3rd power, we multiply the 8 and 3 and get 24. Power rule B is similar. The only difference on this one is that we may have more than one factor inside those parentheses, and when we do, we give everybody that is a factor an exponent, and we take each individual base and its exponent and multiply the exponent of every base by the exponent that's on the outside. So 2x to the 2nd to the 3rd power becomes 2 to the 1st x to the 2nd. For the 2, we multiply the 1 and 3 and get 3. For the x, we multiply the 2 and 3 and get 6. 3x to the 2nd, y to the 1st, all to the 3rd power, we give everybody an exponent. For the 3, we take 1 times 3 and get 3. For the x, we take 2 times 3 and get 6. For the y, we take 1 times 3 and get 3. You can work it out the long way using the definition if you want to, and that example is explained there. On power rule C, that problem looks like a fraction. So on that fraction, it just says that everybody gets the base, everybody gets the exponent on the outside, just like in the previous example. So 2x divided by 3y to the 2nd, all of that to the 2nd power, means that the 2 and the x have an exponent of 1. The 3 and the y to the 2nd, the 3 has an exponent of 1, the y has an exponent of 2. So on the top we have 2, 1 times 2 gives us a 2 for its exponent. X has an exponent of 1, 1 times 2 gives it an exponent of 2. On the bottom in the denominator, 3 has an exponent of 1, 1 times 2 is 2, and the y has an exponent of 2, so 2 times 2 is 4. So we can express that one as a fraction like. On page 15, there's a summary of the power rule, so I would recommend that you take something like this and write some examples that make sense to you. On the following pages, on 16, there are problems with answers on 17. On page 18, there are more problems with Answers on page 19 and 20.